Welcome to our first session in the Advanced Python Programming course. In the first session, we'll be looking into a feature of Python called Lambdas. So the agenda for this session would be a basic introduction to what a Lambda is, the syntax that you'll be using to create a Lambda function, some simple examples to help you understand how to use a Lambda function, and then we'll be jumping into the various characteristics of Lambda which are very important to understand to effectively use them. Then we'll be looking at various use cases for applying Lambdas. We'll also look into when you're not supposed to use Lambdas, when it will prove to be having a negative effect on your code. Then later on we'll look into some practice questions that you can use to check how much you have actually understood whatever we have covered in this session. And later on you'll be given some more questions which you can try to solve by yourself to understand how much you have actually understood. And those questions will be discussed in the next session. So let's jump into the session now. Alright. So we all know basic functions, right? How do you do that? You use a def keyword, you use a function name. If you want to pass in some arguments, so just create some parameters, p1, p2, followed by a colon, and you do whatever you want to do inside. Now here I'm just going to add up p1 and p2, alright? So I'll use a return statement. And when I want to invoke this, what will I do? I'll use a function name followed by arguments. So when I run this, it is just as simple as invoking this function, and it returns me the value. Alright, so this is how we use a function. Now where do lambdas come in? Lambdas are also basically functions, alright, but they are anonymous functions. Anonymous functions are nothing but functions that do not have a name. And when will you use this? When you have simple one-line statements. Now as you could see here, see, all this function did for me was adding up the two parameters p1 and p2, and say I'm just going to use this function in one or two places in my code. Now when I'm debugging the code and I get some error, now if there is some error being pointed out to you for this function, what will I have to do? I'll have to go back to the function definition, check what is being done there, and then change it. All this is too much hassle, right? So instead of all this, what Lambda helps you do is, it will just help you to define the function in place. That is, here instead of invoking the function, I'll be writing the function body itself at the place where I'm using the function. So when there is an issue with the code, it is as simple as just taking a look at the function definition that you're given here, right? So lambdas are nothing but anonymous functions, or functions that will not have names, and they will only be having single small expressions. A single the body of the lambda function will only have a single expression, which will be for, like we saw, we are adding up two variables. That is a simple operation, right? So for such constructs, you can substitute the function with a lambda, because you're not going to be using it extensively over your code, over different files or anything, right? So for such small functions that will be used only once or twice, or very few times inside your code, you will use lambdas. And most use cases of lambda deal with passing them to higher order functions. Now what are higher order functions? Higher order functions are functions that take in other functions as arguments, right? For example, you have the map function. So the first argument of the map function is nothing but another function that will apply some processing to your second argument, which is some iterable like list or tuple. Okay, so the main purpose of lambda is to use anonymous functions with that is without the function name, and they take in, and they are very simple functions. All right, so let us look at the syntax for creating a lambda. So this is the syntax. The first word here is lambda, which is a Python keyword. So this tells Python interpreter that hey, I'm creating a lambda function now. Okay, followed by a space, and then you have parameter definition or the arguments that you're passing in. Okay, so you can pass in as many arguments as you want. We will look into that in the subsequent slides, how we'll pass in the arguments to lambda, followed by a colon. All right, and then finally you have the expression, which is the body of the lambda function, what the lambda function will actually do with the arguments that you are passing to it. All right, so this is the basic syntax of lambda. I hope this is clear. So let us look at a simple example for lambda. Now, as you can see here, I have created a function called increment by 1. What this does, it takes in a number as its parameter and it will return the value of that number incremented by 1. Now, the same thing I can do using a lambda. See here, I've used a lambda keyword followed by the parameter, which is the num colon. What the body is the body of the function. It's just num plus 1. So when I want to use this, can you see here, function, how do we use them? We give the function name followed by a parenthesis and whatever parameter argument you're passing to it. The same way you use the lambda. You see here I have assigned the lambda to an identifier called my first lambda, just for understanding purpose. But I'll tell you in subsequent slides how you can use lambda directly in this place. Okay, so I have used my lambda, and how do I invoke it? Same way as a function. You use a parenthesis and pass in the arguments. Okay, now I've created another lambda here. See here, it is taking two parameters, a comma b. Okay, a and b. What this does, it gives me the product of a and b. So here, see, I've invoked this lambda as well, passing in two arguments 4 and 5. So the code output here would be, see, for function, for lambda, it does the same thing. All right. Now we will just take a look at this code. It's the same thing here. Okay, I've created the function, I've invoked it, I've created a lambda. Now see here, I've defined the lambda directly in the place of this function here. I have used a lambda keyword, num is the parameter. What it does, colon num plus 1. So it increments the value of num. So it returns num plus 1 to me. How do I invoke a lambda? I use another set of parentheses and I pass in the argument. Now see, this is very important. If you give just this, okay, when you're just defining a lambda, for example, if I'm doing this, okay, just see, this lambda takes in two arguments a and b. Don't bother yourself with this equal to zeros for now. Okay, it takes into parameters a and b. It returns a product. Now if I just do this, what will happen? See here, I have passed in default values. Now let's see what it will print out to me. Can you see here, the function call got called and it's returned 8. 7 plus 1 8. Again this lambda, this got executed and it has returned 8. But can you see here, it is just saying function lambda. So it is returned me the lambda object. It's not given me any useful value. Why is that? See, when you're just defining lambda, Python will just put the statement there. It will not execute the lambda. If you want to execute this lambda, what you should do? You should include a set of parentheses definitely. Only then your lambda will be executed. Otherwise, only your lambda object will be, see here, 0 into 0 is 0. This got executed and now I'm getting the proper usable value. So when you're defining a lambda, define it inside parenthesis followed by another set of parentheses where you pass in the values, okay, or the arguments. If you do not use this set of parentheses after defining lambda, your lambda function will not be invoked. It will just get defined at that place. All right. So it's very important for you to understand that. As a beginner, when you're using lambda, this is a common mistake you will do. Okay. So I hope you understood it. Just to recap, I have opened a set of parentheses. I've used the lambda keyword to define the lambda. Use the lambda keyword and any argument I want to pass to it, followed by a colon, and then I have given the body of lambda. What it does, it just adds 1 to my number. And to invoke the lambda, what do? I follow this by another set of parentheses. Inside that, I'll be passing my arguments. So this is the basic syntax for using lambdas, right? Hope this is clear. Now we'll look at the various characteristics of lambda. Now it is very important to remember these characteristics if you want to use lambdas properly. Alright. So as we have seen, they are anonymous functions. That is, these functions have no name, right? And if at all you want to assign an identifier to lambda, as per PEP 8, now this Python enhancement proposal, if you all know, these are a set of guidelines put forward by the overseers of Python to follow, which should be followed in your code for better readability and better usage. Of course, it will not give you a syntax error, but it is good to follow rules. So according to PP8, what you're not supposed to do with lambda is, do not use an assignment statement to assign the lambda expression like we did here. Okay. So we had seen in the code example, right? What I did, I had given my lambda and I did this, right? Say lambda x plus 1. Now when I want to use it, I'll be using it like my lambda. I'll be invoking it like this. Now according to the recommendations, do not use this. You are not supposed to assign a lambda function to an identifier like this using the assignment statement. Alright. So here it is. So lambdas are anonymous functions. You're supposed to use them without a name. If at all you want to use a name, you're supposed to use the def keyword. Okay. Now here, as you can see, I use def. I give the lambda a name followed by the parameters, and here I use a return statement. Now what does this do? It gets me back to the ground zero. Again, I'm just defining a function here. So there's no point in using a lambda, right? So as much as possible, it is better to use lambdas without any names at the place itself where you want your lambda to be used. Okay. Do not use identifiers with lambdas. They rob it of the very purpose of lambda, right? Okay. So the next characteristic is expressions. Now a lambda is supposed to contain only one single expression. Expressions are anything that will return you a value. For example, addition. A plus B is an expression. A minus B is an expression. Okay, A greater than B is an expression. So anything that will return you plausible value is an expression. But when I say del A, okay, that is not an expression. See, del is a statement. So in lambdas, you're not supposed to use statements. All right, you're only supposed to use a single expression. And expressions also, you cannot use multiple expressions. Like I cannot do something like this. Okay, now see here. Now I have created a variable called element which stores hello. Now this is a single expression. Can you see what the lambda does? It appends there to the string, converts it to a lowercase and then appends there. Okay, so this is a single expression. Now I cannot do something like after this. I cannot do sum underscore string dot upper. This is also an expression, right? It will return you some value, but I cannot do this. Lambda doesn't allow me to include more than one expression, and it definitely will not let me include statements. Now can you see here in the, in these two lambda definitions, I have used one del statement and in another one I have used the return statement. Now these are both statements and lambda will definitely not allow you to use them. See, you will get a syntax error. Alright, so lambdas, if you want to use them, you're only supposed to use single expressions inside them. Nothing else is allowed. Alright, so moving on to other characteristics. Now with respect to arguments, lambdas can take any number of arguments. It can even take 0 arguments. Now if you see here, see, I can even create a lambda function which doesn't take anything. It doesn't take any input. So I can just say lambda keyword followed by colon and it returns some value. Now when I execute this, can you see here? See, this was the first one where we passed in the hello here, right? This is the output. Now here, this is the output for this lambda call. So what it did, it returned me hello no parents. I'm just printing it out. Now can you see here, I have, though there are no arguments to be passed, still to invoke the lambda I have to use this set of parentheses. Otherwise my lambda function would not have been invoked. Alright. So lambda need not take any parameters, or it can take any number of parameters. Alright. Then arguments can be of any type, just like functions. So you can pass in an integer, a string, even class objects to lambda. And another thing is you can even pass a function to the lambda as a parameter. Now here can you see I've created a lambda function. The first parameter is something called fun, and the second parameter is a. Now can you see the body? This is the body. Alright. So what it does, fun is actually a function name. Alright. So it is invoking fun and then adding that result of fun to a. Now how I have invoked this? Okay, this is my, so far this was my lambda definition. Alright. Now how am I invoking this lambda? See, in place of fun, which is a function call, I'm again passing in another lambda. Can you see here? Lambdas are also basically functions. So I'm using the lambda keyword and I'm returning the value 23 from lambda. So can you see this lambda is actually taking on the lambda as its argument. So that's also perfectly legal. So 23 plus 23, it is going to give me 46. Alright. So lambdas can take in any type of arguments just like a normal function. Then multiple arguments are to be separated by comma, like we have already seen here. Can you see? See, this was multiple arguments, fun and a. Now they have to be separated by commas, just like in functions. But a major difference is the arguments will not have any parentheses. So when I do this, alright, like function, it's going to give me a syntax error. It's going to tell me, no, you're not doing something with lambda, you're doing something else. See, lambda expressions cannot be parenthesized. Alright. So you're not supposed to parenthesize lambda expression, arguments in lambda expression. Alright. So that is a syntax error. No type annotations allowed. Now type annotations in Python were introduced for some libraries, where what those libraries will do, right? Type annotations, how will I define it? Now say I'm defining a function. Alright. Now usually this is how we define a function in Python, right? Now as per type annotations, I can actually say this a is supposed to be int and b is supposed to be a string. So what the library, the type checking libraries will do is, if you get any error when you are running or debugging, they will use these type annotations and they will give you a proper error message saying, see, a function was actually expecting an integer argument a, but you pass something else. So for such libraries, these type annotations were introduced in Python, and these are definitely not allowed in lambdas. Okay, so when I create a lambda function like this with type annotations, it will tell me, hey, you are doing it wrong. Okay, so this will give me a syntax error. All right, type annotations are not allowed in lambdas. And the lambda arguments can be any type, like I said, and they can also be positional, keyword, variable arguments, and variable keyword arguments. We'll look at this one by one. So positional arguments, so far what you have been using is positional arguments, right? So based on the position, the arguments will be assigned to the parameters. So here what this lambda function is doing, it's basically dividing dividend by your divisor and it's giving you a quotient. I've used the float division here. Okay. So I'm passing in 4 and 2. So as per the position, 4 will get assigned to dividend and 2 will get assigned to divisor. So it will be 4 divided by 2, which is 2. I'll just run this. Right? So it is giving me 2. So these are positional arguments. You can also use keyword arguments with lambda. So how do you do that? See, I define a lambda function. This is the lambda function. I'm taking in 2 strings and I'm just concatenating them. Okay. Now when I'm invoking it, the first string I'm passing it as positional argument. The second string I'm passing it as a keyword argument, some other string. Okay. So when this gets passed, again I'm appending the first to the second, right? So some other string plus some string. So this will give me first and second. So lambda basic, all this is to say that lambda will allow keyword arguments as well. Then moving on to the variable arguments. Now, if your function, if you do not know how many arguments you'll be passing on to the function, so in that case, you'll be using something called a variable arguments, right? Which is specified using a star in Python. So lambdas are also do support these type of arguments. So when I do this, I can specify it as lambda star nums, and what this function is doing is just finding a sum of all of the values in the nums argument. So I'm invoking it with 1, 2 and 3. I'm passing in 3 arguments in this case. Okay, so it is giving me 3 plus 2 plus 1, which is 6. Variable keyword arguments again, as you can see here, see I've used both variable and variable keyword arguments here. So star nums is a variable argument parameter, and star nums too. See, for keyword arguments, like we know in Python, they are supported using double star. When it's a single star, it tells Python that these are variable arguments. And when it's double star, it tells Python that these are variable keyword arguments. So how do I use them? So see here, now first I have found the sum of nums, the variable arguments. I'm multiplying that sum with what? Sum of the keyword arguments. Okay. So to get the value of the keyword arguments, I'll be using the values function, right? So I'm finding the sum of nums to that values. Now can you see how I've used here? 1, 2 and 3 are variable arguments, and n1 and n2 are variable keyword arguments, right? So lambda very much supports variable arguments and variable keyword arguments as well. Now moving on to other characteristics of lambdas. See, a lambda will have access to the data contained in enclosing scope. What this means? Now, for example, say I have A is 2, okay, and B is 4. I'm having 2 variables. I'm using an if block if A less than B. Okay. Now inside that, what I'm doing, I'm creating another variable called LA. Okay. And say now I move on to create a lambda function. Alright. So what my lambda? Now I'm just creating a lambda function. I don't want to pass in any argument, or say I say A. Some argument say num. Okay. Now what this lambda wants to do? It wants to replicate this by num times. Okay. So I've created the lambda to pass in. I'll just say 2. Now can you see here this element variable I have not passed into lambda. Where is it defined? It's defined here. Now will this actually create any error? Let's see. Okay. So can you see? It did not tell me any error. It just ran. So what does this mean? This lambda has access to the variable element, which is defined inside its enclosing scope, which is the if statement. Okay. So lambdas have access to the values inside the enclosing scope. This is what it means. Next, you can apply decorators to lambdas. Now, do not rack your brains with what a decorator is if you're not aware of it already. Just for a basic introduction, decorators are nothing but functions that will help you extend another function. For example, say you have defined a class method that does something. Okay. You are using which is defined by some other person, some other user, and you want to add in some more functionalities to that method, to some say method 1, but you don't want to touch the actual method in the class. So in that case, you will be using a decorator to extend its functionality. Okay, don't confuse yourself too much with this. We will be looking into this in the subsequent sessions in the course. Okay. Just to, at that point of time, I'll tell you how to use decorators with lambdas. Just be aware that you can apply decorators to lambdas. So basically, you can extend the lambdas functionality using decorators. Okay. Then they can also be, lambdas can be used as closures. Now closures are again functions that will help you save the state. See, now whenever you execute a function, once the function finishes execution, you will lose its state, right? You will lose the values of variables that were assigned inside the function. But closures will actually help you freeze those states. We will also be looking into this in subsequent sessions. Okay, so you can use lambdas to actually create closures. All right. Then lambdas can be tested in the same way as normal functions. When I say tested, I mean unit testing. So you can apply unit testing to even lambdas. That also we will be looking into subsequent sessions. We do not want to complicate this session, which is the main focus is on lambdas. Okay. So in subsequent sessions, we'll be looking into decorators, closures, and unit testing. I will show you how you can use those with lambdas. Alright. So moving on to the main use cases of lambdas. So where will I actually use lambdas? So one example is the sorting. Now we know that we have a sort method, okay, for list, right? So the first parameter will be, you will have a parameter called key parameter where you can use it to customize your sorting. So here, as you can see I have a list called nums, which in turn is having 3 tuples. Now I want this list to be sorted based on the value of the second element in the tuple. So I can specify the key as I'm using a lambda function. It is taking an input, okay, and for that and so here I'm returning n1. So what I'm doing here basically, I'm sorting nums for each element in nums based on the second element of nums, which is the number name. I'm sorting it. Now let's just see, run this and see so that you better understand. Okay. Now what I did was I created one, right? 2, okay. So this is my list. Use a normal sort. Now say nums dot sort. Now what this will do? Just print nums. What happens? Now just for clarity purpose, I'll just change this to 2, okay, and I'll put now 1 here. Okay, so now what this is doing, it is by default taking the first argument and is sorting. All right, now say I want to sort based on the number name. So now what I will do, I'll specify the key to base the sorting on, right? So here what I will do, I'll specify a lambda function which will take in every element in the nums list, and I want to base the sorting on the number name, so which is the second element in the tuple. So I'm doing n1. Now when I run this, what will happen? See, it is sorting the list based on the number name. So O comes first, followed by T, TH comes first, followed by TW. Okay, so this is a basic use case of lambda function. So we can use it to specify the key function in the sort function, which is a higher order function. Second use case is filter. Like, can you see this function? See what the filter function will do. It will extract only required elements from your iterable and will return it as another iterable, right? So this filter function is taking a lambda function as its first argument, where I'm passing in every element of the nums list, which is a tuple, and only if the first character in my number name is T, I return that. I want that. I want only those elements. So what I do, I take n of 1, which is the second element in the tuple, and when I say 0, it is the first character in that word. So when only it is equal to T, I want it to be returned. Okay, so like we all know, the first the function that you specify in the filter should return a true or false, right? So I create a lambda function. It takes in every element in the iterable, and in that element I want to look into the second member, which is the number name, and for that second member I want to check the first character, which is and this should be equal to what? T for me. So only when this is true, I want the lambda function to I want the filter function to return that particular element, otherwise don't return. So the second argument will be what? The nums. Alright, now to look at the result, I'll have to convert the return iterable as a list. Alright, okay. Now can you see only 2 and 3 are returned. So this will basically give me a true or false value, right? So based on this value, the filter function has filtered out only 2 and 3 from the list. Okay, so I hope this is clear how you use a lambda inside a filter function. The next use case is a map function. Now map, what it does, it will basically apply whatever operation you're specifying as the first argument to every element in the iterable. Now as you can see here, I'm using a lambda function where it is multiplying my first argument by 2 and it is just returning the second element in the tuple as such. So what will happen in this case, we'll just take a look. So next up, what I'll be doing is, okay, so what you will be doing, I'm using a map function. The first parameter is a function, so I'll use a lambda function. So for every element in the list, what I want to do, I want to return a tuple, okay, where the first element is multiplied by 2 and I'm just returning the second element in the tuple as such. Okay, so this is my lambda function and this is supposed to be applied to nums list. Okay, so when we see here, see, can you see 2 got multiplied by 2 and 4, 1 got multiplied by 2 and 3 got multiplied by 2 and the number names are just returned as such. Alright, so this is one more example of using lambda function with the map function. Next we have the reduce function. Now what does reduce function do? It will basically apply some processing to all the elements in your iterable and reduce it to a single value. Now for example here, can you see, I'm trying to find the smallest element in this nums list. Okay, so here it is 1. So what will I do? I'll use a reduce function. Alright, so the first element should be a function. So I'm using a lambda function n1 comma n2. Now I want n1 to be returned if the first element in the tuple is less than the second element in the subsequent tuple. So basically what will happen, this n1, this will be n1 and this will be n2. Okay, now what this will do, it will compare n1 of 0 which is 1 with n2 of 0 which is 2. Now whichever is less, so here we can see n1 is less. If this is less, if n1 is less, then just return n1. Otherwise, I want to return n2. So what I'm basically trying to do, I'm trying to find the smaller of the two numbers in the first element of the two tuples and I'm just returning that particular tuple. Okay, so this helps me find the smallest element in this list. So let's just execute it out and see. Alright, so what I will be doing here, so again, I don't want to do all the fancy typing, we'll just jump into the code. Okay, now reduce has now been moved to the functools module, right? So we need to import functools. Alright, so here I'll be using functools.reduce. Alright, so first will be the function. So lambda, it has to take 2 of the elements from the list, which is first n1, which is the first tuple, n2 is the second tuple. Now in this, I want to return n1 if my n1 of 0 is less than n2 of 0, right? Otherwise, I just return n2. So if the first element in n1 is less than the first element in n2, just return n1 because that is the smallest element. Otherwise, return n2. It's as simple as that. Okay, so and what do I pass in? I pass in nums. Alright, so now this should be pretty much fun. So can you see it has returned 1. Okay, So this is how we use lambdas with reduce. So basically whatever you want to apply to various higher order functions. Okay, so in map I'll be applying some processing to every element. So that I'll have to specify in lambda, and that will take in every element. So there'll be one argument. In reduce, basically for my reduce function, see, reduce functions will take subsequent elements. So you need to specify two arguments, and whatever you want to do inside the lambda function, you do it, and that is specified using the lambda function. Okay, I hope you understood all these use cases with sort, filter, map, and reduce. Okay, so next we move on to the important topic: when should we avoid lambdas? See, the lambdas can be very tempting to use, because when you're using just single expressions, I'll use lambda everywhere, or maybe I'll use lambda, I invoke another function from inside lambda, so that will make my code readable easier. So you will have all such kind of thoughts. It is very easy to get carried away by a new feature, right? So we'll just see when it is better to avoid lambdas. So first is, you're creating a workaround for something lambda doesn't support. Now an example for this is, see, we know that lambda doesn't support statements, but somebody is so smart as that they'll define a function, they use statement. See, this is just a simple example that I've given. You can even have function which will have some complex processing going on in there. Okay, and that they're using it in this lambda. See, this is very much not required, right? It is pointless to do something like this. So lambdas are supposed to define only single expressions. They use for very simple functions where which you can take a look at wherever you define lambdas. So doing this again defeats the very purpose of lambdas, because again you have to go back to this function and then take a look. So avoid such use cases where you are trying to violate the very characteristic of a lambda. Okay. Second one is, your lambda expression becomes very difficult to read. So can you see this lambda expression? It has, there's not much going on here though. It's just taking a letter, and it is checking if the lowercase of that letter is in the AIO list. Basically what this lambda is doing is, it is taking a list and is checking where it is filtering out those elements that are vowels basically. So see, when I write something like this, so when some other programmer or even you in the future, if you go and look at your lambda function, it'll be so confusing, right, when it is so verbose. So when your lambda function becomes very difficult to read, it is better to just avoid using lambda, just create a function and go and just use a function call. Alright. And very important is, you should never use lambdas inside a class method, because first thing is, it doesn't support docstrings. See, docstrings are very important for classes, because basically those tell you what that method is doing, right? So when they don't support docstrings, you will when some other program is going to have a look at your code, it will be very difficult for them to understand what you're trying to do using a lambda function. So it's better not to use lambda as class methods. Second reason is, they will not have access to the instance or class members. Okay, so because instance of class members will be defined in init or out, or basically inside the class itself. So they will not have access to those members due to encapsulation purposes. So you cannot use lambdas to access them. So basically it renders it useless, right? So lambdas should not be used as class method for this purpose. And again, it will violate OOP principles like encapsulation abstraction, because when you're using a variable inside a lambda function, anybody can see, if you're able to access any data inside a class, then that defeats the very purpose of a class, right? So it's better to avoid lambdas, because lambdas are very vulnerable, and you can easily get deduce the type of data or the data that is being used in lambdas. So it's better to avoid lambdas as class methods. So we have come to the end of this session now. Okay, so we'll just have a recap of what we have seen for lambdas. So they are small anonymous functions, they are nameless, and they are supposed to be small simple functions. They can contain only a single expression. Multiple expressions or statements are not allowed. They can take 0 or any number of arguments like we have seen, and they can take any type of arguments on the basis of both data type as well as type of argument like positional, keyword, variable positional, variable keyword. Okay, the main purpose is they are used with higher order functions. or as key functions. Key functions like we saw with sort, right? You specify the key function using lambdas. And higher order functions we have seen map, filter, reduce, all of those are higher order functions. And it is better to avoid excessive usage, because when you use lambdas and you get any error, all your debugging tool will tell you is there is an error in this lambda. It will not pinpoint to the actual reason that you're getting the error. For example, you may be adding a string and a number. So it'll just tell you there is an error in this lambda. It will not tell you the reason you're getting the error. Okay. So it will be very difficult for you to pinpoint what is the exact reason for the error. So it's better to avoid excessive usage of it. And always, if you're thinking, okay, I'll go ahead with lambda, just make sure your decision is justified. Make sure none of the basic characteristics of lambda are violated. Okay. If any is violated, just go ahead with a normal function. All right. So this is all about lambdas. Now we will look at some practice questions. Okay. And see how much we have understood lambdas thus far. Okay. So consider the code snippet. So print lambda, it is taking in 3 arguments A, B and C. What it is doing, the first it is opening braces A plus B and B comma B greater than C. Okay, and to this I am passing the 3 arguments. So what will be the output of this lambda function? Now see, we have given the lambda function. I have opened a parenthesis here. Now when you're specifying some elements inside a parenthesis, it means you're creating a tuple. Alright. So basically this lambda function is returning a tuple where the first element is sum of A and B and the second element is a comparison between B and C. So when I'm passing 1, 2 and 3, sorry, A plus B is 1 plus 2, which is 3. And B greater than C in this case, no, it is false. Right, 2 is less than 3. So basically it will return a tuple where the first element is 3 and second element is false. Now B is wrong, there is no syntax error in this, it's perfectly fine. C, if you see these two look same, but can you see this is a tuple, this is a list. But here the lambda is returning a tuple, so C is also wrong. And D, you will not get a 0, you will get a true or false value. So the right option is answer A. Moving on to the second question. What would be the result when the code given below is executed? So here what this lambda is doing, it is taking in 2 arguments x and y. Now if x is greater than y, it is returning me x or it is returning me y. Basically you are trying to find the greater of the 2 numbers, right? So 2, will it be the answer? No, definitely not. False? No, this is returning me the actual argument. So true or false is out of the question. 3, yes, it will return 3, it is returning the greater of the 2 numbers. There is no syntax error in this code. So C is the correct answer. The next question. Which of the following options would return a dictionary that contains the elements from list 1 as keys and corresponding elements from tuple 1 as values? So this is a slightly complex question. So you have list 1, which is 1, 2, 3, and you have like a, I'm sorry, this is supposed to be a tuple. It's supposed to be contained inside small braces. So how do I do this? Which function can I use? We'll look at it one by one. Okay, so I'm creating a dictionary. I'm using the dict function. So there I'm creating a lambda function. It's taking an argument I. Okay, so what it is doing, it is taking the list 1 of I and so it is defining that as a key. I've opened the parenthesis here, right? The curly braces and tuple of I. Okay, so I'm passing in I here for I in range of, see what this will, what is this doing for every element in list 1, it is passing in I, the number I, the index basically, and is creating. Now this will definitely not create a dictionary. This will give you an error actually. Okay. Now looking at option B, see, because dict, you cannot define a dict like this. So when you're passing in some values to the dict function, you're supposed to pass in tuples or rather when you're defining, you will not give it inside curly braces. The very syntax is wrong, right? So A is ruled out. Now B, when you see lambda L comma T, it is taking 2 elements L and T, and what it is doing, it is just creating a tuple with L and t. Okay, and what I'm passing the arguments L comma t for L comma t. See, first you execute this for loop. For L comma t in, I'm using the zip function. So what does zip function do here? It will basically combine these two iterables and create a tuple of corresponding elements. So when I say zip of list1 comma tuple1, what the zip will return is the first element will be 1 comma cookie, second element will be 2 comma cake, and third element will be 3 comma peanuts. So for every element in the zipped construct, I'm passing those. So this is very much correct, right? So what happens here? I'm creating a tuple out of corresponding elements in the list and the tuple, right? And I'm passing it to the dict function. So dict function will definitely work. You can pass in a list of tuples to the dict function, and it will create a dictionary value with with the first element as a key and the second element as the value. So B looks right? Next, we are using the map function. Okay, so map lambda L comma t. We are creating a dictionary with L as the key and T as the value dictionary element. Now this will not work because map function will only return a map object. If you want to use this with dict, you're supposed to convert the convert the return value using a list function or a tuple function, right? So this will definitely not work out, just because it is missing the conversion. The list, this map object is supposed to be passed into another function, say list or two. Okay, so this will not work as well. Then I'm using a normal for loop for for I in range of len of list1. I'm creating a dict with lambda I as the, I'm creating a lambda function. See, this is also, like I told you already in first case, like in A, this is a wrong syntax for creating dictionary. So the correct option, like we have seen, is option B, right? So hope you've understood the questions thus far, right? Any questions, feel free to shoot it out to me. I'll be glad to answer all your questions. Now I have provided a set of 3 questions which you can try to solve by yourselves so that you can better understand lambdas. Now all of these questions I will be discussing in the next session. So we will know how lambdas actually work. Okay. Thank you so much. That's all for the first session.